Alright, here we are in Chapter 7 review. Sorry about my voice, it's a little scratchy lately, but you have to deal with it, I guess. Chapter 7, this is the test, so we're going to start right with number 1. It says the ratio of the measures of three sides of a triangle is 9 to 6 to 5. Its perimeter is 100 inches. So what we're going to do, this is for number 1, we're going to go 9x plus 6x plus 5x. The x represents that constant, that number that all these are being multiplied by. So this represents this angle, or sorry, the length of this side. This represents the length of a second side and the length of a third side. And when you add them all together, what does it add up to be? Well, that's the perimeter. It adds up to 100 inches because we're talking about the lengths of the sides of a triangle. So they all add up to 100 inches, and we just saw for this. So 9 and 6 is 15, and 5 is 20x equals 100. And x is 5. Divide both sides by 20. But that's not the question it asks. It says find the measure of each side. Remember what each of these are. Each of these, with the x multiplied by it, is the length of each side. So now we find that common factor of 5, and we multiply everything by 5. So the one side will be 9 times 5, which would be 45. And then this side right here would be 6 times 5, which is 30, and then this third side would be 5 times 5, which would be 25. Those are the lengths of the three sides of this triangle. Okay, number 2, all you're doing is just solving for x. It's kind of just like an algebra problem. So what we do when we have a proportion like this, we just cross multiply. So we multiply 3x plus 1 times 7, and I'm going to write it like this, equals 14 times 5. And I'll just do it like this, or you can put it in parentheses. Alright, distribute the 7, it's just basic algebra right here. Plus 7 equals, see, 14 times 5 is 70. Subtract 7 from both sides, 21x, subtract 7 is 63. Divide by 21, and x is, let's see, 30. Well, it's not anything, it's just 3. I was going to say 33. That's crazy. So it's just 3. And that's all there is to that. And they're setting you up, okay, because in this chapter they do a lot of similar figures, and then they set up proportions. That's all they're doing with this. Same idea, we're just going to cross multiply. So it's going to be 5 times x minus 3 equals 4 times x plus 1. Distribute the 5 and distribute the 4. Get the x's on the same side, subtract a 4x from both sides. I don't think I have to show that, do I? That'll just give you an x. Add a 15 to both sides. So if I add a 15, I'll just show this. Add a 15 to both sides. X is 19, and that's all you have to do. Let's move on. Alright, this problem number 4 is very similar to that first problem we did, except we're not talking about the sides of a triangle, we're talking about the measures of the angles of the triangle. It says the ratios have a measure of 5 to 4 to 7, but it doesn't say what they total to. They don't have to, because you know that the angles total to 180 degrees. So I'm going to do the same basic thing. I'm going to go 5x plus 4x plus 7x. Now this time it equals 180 because there's 180 degrees total in this triangle. Let's add them up. That's 9 and 7 is 16x equals 180. And we're going to divide by 16, and making sure that's right. Okay, we divide both sides by 16. I had to throw that in a calculator. Thought I could do that in my head, and I couldn't. It's 11.25. But that's not our answer. It says, what's the ratio of the measures of the three angles? We want to find the, or not the ratio, but the measures of the three angles is what we want to find. So we found x, we just have to figure out, remember, this is going to be one angle, that's going to be another one, and that's going to be the third one. So we just plug everything in. So it's 5 times 11.25. And then it's going to be 4 times 11.25, and then it's going to be 7 times 11.25. So if we multiply that by 5, we get 56.25. If I multiply it by 4, I get 45 degrees. These are all in degrees because they're angles. If I multiply it by 7, I get 78.75. degrees. And those are the three angles. If you added them all up, they'll add up to 180, and those are my angles right there. Okay, number 5, two similar squares have a scale factor of 2 to 5. All right, so we have a small square and we have a large square. The small one would be the 2, and this would be the 5. Now, it doesn't mean it's actually like, 2 square inches or anything like that. Let's see, 2 scale factor. We're talking perimeter, okay? It doesn't mean that this is like 2 inches and this is 5 inches necessarily. It just means for every 2 you go on this one, you go 5 on this one. So this one's definitely going to be bigger. So we rate our ratio is 2 to 5. And it says the perimeter. Now we can, if you look in this chapter, it talks about relating the scale factor to the perimeter, and you can do this. It says the perimeter of the large square is 45. So where are we going to put the large square? Not across from this 2, the smaller one. We're going to put it across from the 5, which is the larger one. I'm just showing you how to do these. I'm not going through a detailed explanation of why. We did that when we first taught the chapter. I'm just showing you how to do them. All right, so we want to find out what the let's see. Okay, I knew I was missing something. The question says find the perimeter of the small square. I guess I didn't copy that when I put it up here. So we want to find the perimeter of the small square. I'm like, we're missing something. So this would be the perimeter right there of the small square. Perimeter of the big square, perimeter of the small one. These are the ratios of the small to the big. So we just cross multiply. 5x equals 2 times 45, which is 90. Divide both sides by 5. 90 divided by 5, just throw that in a calculator, and you get 18. So that's the perimeter of the small square. Alright, this says to solve for x. So there's an x right there, there's an x right here, but we have to see what we've got going on right here with these two figures, these two quadrilaterals. Okay, I was looking at this before I started, and it said just find the value of x. But what I should have said, there's not enough information here to see that they're similar. What should have been on here, apologize for that, is that these two figures are similar to each other. So if they are similar to each other, we can actually solve for x now. So if you take a look, if I was able to take this, I can't really do this on here, but if I was able to rotate it and flip it around, then this and this would look very close to each other. In fact, similar to each other. So which sides would match up if I was able to do that? Remember, I want this angle being down here on the bottom left like this one, and this P over here being on the bottom right like this one. That's all I have to do is just twist it and flip it, and it should look just like this. So which sides match up? Well, the 2 and the 3 would match up. So if they're similar to each other, I can set up a proportion. So I go 2 to 3, and now this side right here, BP, this x plus 3, would match up with this. Now they're not exactly equal to each other, but I can set up a proportion. So I can go x plus 3. That's the smaller one. I'm comparing the smaller one to the larger one. Okay, so 2 to 3, small to large. This is the smaller side here, and the larger side is the 2x plus 2. There's my proportion. Now I just do what we did at the beginning of this and just cross multiply and solve. We don't have to write it all out. Let's just do it like this. Let's just do the multiplication right now since I put parentheses around this. So 2 times 2x is 4x plus 4 equals, multiply these, distributive property, 3x plus 9. Subtract a 3x from both sides, I get x. Subtract a 4 from both sides, and I just get a 5. And the question says just to solve for x, you don't have to find the lengths of the sides or anything. But this should have said that these two figures were similar to each other. Okay, they don't give any pictures on this one, they just describe it for us. So our triangles don't really have to be to scale. So let's just pick a couple triangles here. Triangle ABC is similar to triangle DEF. I was supposed to make that italics, but I didn't. That's okay. So let's do this. Let's just stick any triangle on here. We'll call that one ABC. And we'll make it about like that. And then they're similar to each other, so I'm just going to make one bigger than the other. That's all. Alright, so let's call this one ABC and DEF. And really, it doesn't even matter which one's bigger. It doesn't make any difference. We just want something to look at so we know how to solve this. Let's put some stuff in here. AB is 5, BC is 6, AC is 7, DE is 3. So we don't know this and we don't know this. I'm going to call it X and Y. So we just find a scale factor. Look at the two sides, the corresponding sides that we know. We know this is 5, we know this is 3, so our scale factor is 5 to 3. Now when we solve for x, we have to make it 7 to x. So we cross multiply. 5x equals 21, and x equals 21/5. And then we do the same thing for y. Keep the same scale factor, 5 to 3, and set that equal to 6 over y. Cross multiply. 5y equals 18. Y equals 18 over 5. So that's what x is equal to, and that's what y is equal to, 18/5. And now you just add them up. I'm running out of time on my video, so I added them up right there, and then I did the division, 10.8, and that's the perimeter of triangle DEF.